Public child key derivation is the process of generating public keys from the seed. This can be done by using a specific set of rules, such as the BIP32 standard. This allows for a more organized and secure way of managing multiple keys and addresses. The HD wallet can generate a large number of public addresses from the seed, with each address having a unique private key. Using a specific set of rules, such as BIP32 and BIP44, allows for a more organized and secure way of managing multiple addresses. This can be useful for privacy and security, as it allows the user to have a different address for every transaction. In addition, HD wallets can also use extended keys, which are a way to represent a node in the key tree and all its descendant nodes. This allows for the creation of a smaller set of keys that can be used to derive a large number of addresses. When it comes to Bitcoin wallets, there is a concept called an extended public key, or SPUB. This key is used to generate an unlimited number of public addresses from a single seed without the need for the corresponding private key. This makes it useful for situations where you need to share a public address for receiving payments, such as on a web store, but do not want to share the private key. By using InSPUB, the web store can generate a new public address for each customer transaction, providing increased security and privacy for both the customer and the store owner. Additionally, InSPUB can be used to monitor the balance and transaction history of all addresses generated from it, making it a useful tool for accounting and auditing. Hardened child key derivation is a technique used in HD wallets to increase security. In traditional child key derivation, a child private key can be derived from a parent private key. However, in hardened child key derivation, a child private key can only be derived from the parent public key, not the parent private key. This means that if an attacker gains access to the parent public key, they will not be able to derive the child private key, providing an added layer of security. This technique is often used when creating a new address for a transaction, as it allows for greater control over the funds being sent. It's important to note that not all HD wallets support hardened child key derivation, so it's important to check the specific wallet's capabilities before using it. In the context of Bitcoin wallets, child key derivation refers to the process of generating new keys from a parent key. The parent key can be a seed, an extended private key, or an extended public key. Child keys can be either private or public, and can also be derived in a normal or hardened way. In normal child key derivation, the child key is derived from the parent key's private key, and the child public key can be derived from the parent public key. This is the most common form of key derivation used in Bitcoin wallets. In hardened child key derivation, the child key is derived from the parent key's public key, and the child public key can be derived from the parent public key. This form of key derivation is considered more secure, as it prevents an attacker who has access to the parent public key from deriving the child private key. Index numbers are used to specify which child key should be derived from a parent key. Normal index numbers start from 0 and go up to 2 to the power of 31-1. Hardened index numbers start from 2 to the power of 31 and go up to 2 to the power of 32-1. Using an extended public key on a web store allows you to generate new receiving addresses without sharing your private key with the store. This is done by deriving new public keys from the extended public key and providing the derived public key to the store. This way the store can generate a new address for you, but cannot spend the funds. In order to understand HD wallet key identifiers or paths, it is important to first understand the concept of hierarchical deterministic wallets, HD wallets. An HD wallet is a type of wallet that is able to generate a tree of key pairs from a single seed. This allows for a more organized and secure way of managing multiple keys and addresses. A key identifier or path is a representation of a specific key or address within the HD wallet tree. It is a string of numbers and letters that indicates the specific location of the key or address within the tree. For example, a key identifier may be represented as M/44/0/0/0/0/0, which would indicate the first key or address generated from the root of the HD wallet tree. The numbers in the key identifier indicate the index numbers for normal and hardened derivation of keys. The numbers before the apostrophes, such as 44 in the example, indicate the normal derivation, while the numbers after the apostrophes, such as 0 in the example, indicate the hardened derivation. Hardened derivation is a technique that is used to increase the security of an HD wallet by adding an extra level of protection to the private keys. This is achieved by making it impossible to derive the private key from the public key. It's important to note that HD wallet key identifiers are used to generate and identify addresses and private keys in a hierarchical deterministic wallet, and the HD wallet key identifier is used to generate a unique address and private key. One important aspect of HD wallets is the ability to navigate the tree structure of the wallet. This is achieved through the use of key identifier, also known as a path, which specifies the location of a specific key within the tree. The path is typically represented as a string of numbers and slashes, with each number representing a child key and each slash representing a level of the tree. For example, the path M/0/1/2 would represent a key that is the second child of the first child of the root key at level 0, a hardened key. This allows the user to easily navigate and identify specific keys within the wallet. Additionally, HD wallets often use a system of index numbers to differentiate between normal and hardened child key derivation. This allows for added security as hardened keys are less susceptible to certain types of attacks.